The University of North Carolina at Chapel Hill is developing a telepresence video wall for enabling informal conversations between remote coworkers. This video gives a brief overview of the project and details a recent image segmentation improvement using graph cuts. In this project, 2 video walls have been constructed at UNC. Each video wall consists of 4 large-screen displays and a teleconference audio system. Eye contact is facilitated by switching between 2 sets of cameras as people approach the displays to speak with one another. The first set of cluster cameras captures a panoramic view of the room. The second set of personal cameras are positioned in front of each display at eye level, so that people tend to make eye contact when they are speaking at a socially comfortable distance. Image segmentation is applied to achieve the best of both worlds using these camera systems. First, images of people and objects seen from the personal cameras are cut out and overlaid over a panoramic background. This enables people to make good eye contact while providing an externally consistent view of the room. Second, image segmentation is used to remove otherwise distracting duplicate image artifacts that appear when a person or object is seen by more than one camera. This process starts by building a background model. Multiple background images are taken before people enter the room. The color of a pixel for any given pixel coordinate in each of the images may have a slightly different value due to image sensor noise. The distribution of these color values is characterized in each pixel using a mixture of Gaussian distribution. Each pixel has a color probability distribution, and together these distributions serve as a background model for determining if pixels belong to the foreground or background. Here, high probability background pixels are shown in white and foreground pixels in black. The problem is, this method fails when people in the foreground are the same color as objects in the background. In this example, the gray color on the probability map indicates that the color of the participants' blue jeans in the foreground are similar to the carpet color in the background. The result is often holes in image segmentation that can be distracting during conversations. The UNC team has implemented a graph cut-based image segmentation algorithm to remove these holes and improve image segmentation. The method incorporates edge information as an additional constraint. In computer vision, edges occur between pixels where the brightness changes sharply. In this case, the graph cuts are used to find edges at sharp discontinuities in the foreground-background pixel probability map. Each pixel is said to be a node in a graph, shown here as green circles. Each node is connected to its 4 adjacent neighbors, the pixel above, below, to the left, and to the right. The weight of these connections is based on the difference in value between these connected nodes. High difference values between neighboring pixels suggest the presence of an edge, and are assigned a low value. Low differences, for example between 2 adjacent background pixels, suggest an unlikely edge candidate, and are given a high value. Each node has an additional pair of connections to a common set of foreground and background nodes. The connection weights to the background node are the values from the probability map, 0 to 1, and the weights to the foreground node are 1 minus this probability. The graph cut algorithm is then used to segment the foreground and background by finding a path through these node connections with a minimum cost. Here's an example of this approach in practice. The left frame shows graph cut segmentation results in red, and results from the original background subtraction method in blue. The segmentation results from the team's graph cut method are much more desirable, and use the additional edge constraint to correctly segment the leg region. Image quality is an important requirement for seamless telepresence collaboration. The introduction of additional edge constraints using graph cuts fills holes that can be otherwise distracting during conversations, and is much less sensitive to people wearing clothes that are the same color as the background. The team is currently working to integrate this graph cuts approach into the larger video wall framework and is enhancing image segmentation even further with stereo depth constraints.